For the social vulnerability layer, I'm using R to adopt the method described in the CVC paper. I'm using percentile rankings for each block group. I already downloaded several block group level variables from Simply Analytics, including the percentages, population age 0 to 5 and 65 and older, poverty rate, percentage of household without a vehicle. Some of the variables are in 2020 block groups and others are in 2019 block groups, so they come in two different shape files. I have extracted these zip files into my R project folder. Remember how to use an R project, right? When you export shapefiles from Simply Analytics, the file name or field names will not reflect the variables you downloaded. There will be a text file though in each zip file containing the variable list. So let's see. So the first file contains age variables and poverty rates. Now let's first load the needed packages. I already installed this, so I'm just loading them. SF is a usable package for vector data, and dplyr contains the function that we will use to calculate percentile ranks. Using strread from the SF package to read shapefiles. Now, first shapefile, I'm calling it age. The file name is very long, so I'm using rename to copy the file name. Copy the SHP file. And don't forget to include the folder name as well, which is the same, just without the SHP part. Cool, now it's loaded. Right, you see these value 0 to value 2, the variables. Let's change the variable names. The spatial data set is stored somewhat like a data frame, so we can use rename that we learned before to change column names. See the variable names I changed? I'm going to use plot to show a preview of the spatial data set, which will create a small map of each single column. Now I can similarly read the other shapefile, which contains percentage of household without a car. And I'm using names function here, which returns a vector containing the column names. And there's only one value variable, so I'm changing it to no car. The next I'm going to do is to join the two spatial data sets into one, because we only need one block group layer. I'm using left join here, which we learned before, but we're not doing a spatial join because we're joining by a common field, in each case spatial ID and the block group name. So I'm using stjob geometry to remove the geometry of the second no-car dataset to use that as a non-spatial dataset. Now I can use a dplyr function %rank to calculate the percentile ranks of block groups by each variable. So this is the function I'm going to use, and this creates percentile rankings of the age 0 to 5 variable, and I can assign that to a new variable in the SVI dataset. I can also use mutate to do this. But if you repeat this for every single variable, now we have 4 variables, not too bad, but if you have more, that's going to be tedious. We can actually use an apply function to apply it to every column you want. Let's see how to do that. There are 3 arguments in this apply function. The first one is the data you're going to use. Here I'm using job geometry again to remove geographic information from the columns I need from SVI, the variables. The second argument means 2 means you want to do column-wise operations. If you put 1, that's operations for every row. And the third argument is the function you want to apply for every column. In our case, it's %rank. So I'm creating a new data set called rank, containing the 4 percentile ranking variables. I'm printing it out so you can see the rankings are between 0 and 1. I'm going to give it a name column containing the block group name so we can use this field to join it back to SVI. All the 4 variables I'm using here indicate greater vulnerability with higher values, so I don't need to reverse anything. We can then create a sum column with the 4 percentile rankings. The CDC paper also used a count variable to flag the number of individual variables with percentile rankings of 90 or higher. We can do it here too. You see, I'm using a mutate function to create 2 new variables, SVI and flag. Row sums obviously calculates the row sums, and I'm using the 4 columns in the rank dataset. And I'm setting NA removal to true because I do have some missing values here. But remember, if you remove them, you're assuming in summation kind of a value of 0, as if these block groups have the lowest numbers in these variables where they have missing values, which may not be actually the case. So if you want to avoid distorting your social vulnerability index, you can consider replacing missing values with the mean or median or the variable. Knowing what row sums does, can you tell what this second line in my mutate does? This first argument here, rank -5 is greater than or equal to 0.9, is a condition judging whether a certain number in the rank dataset is greater than 90%. Right, so it creates a logic table where the value will be true or 1 if it is greater than 0.9, or it will be false or 0 if it is smaller than 0.9. You can move this argument out of the mutate function and run it and see what it does. Alright, now we have our social vulnerability index and the flag count in rank. I will join it back to the spatial dataset SVI. Again, using left join. You see here I dropped the first 4 columns in rank because there are same column names as the values in SVI, and besides we don't need those numbers anymore. Now if you open SVI in the viewer, you will see the 2 new columns joined here. You can also use plot to show a map of the social vulnerability index we just calculated. Alright, now let's export it to a shapefile. You see here the shapefile is created in your R project builder. And don't forget to save your script.